down in the deep subsurface, you could have really slow growing things that are making a living in a number of different ways. The exact proportion of what metabolisms are operating as we get into the deep crust, I think that's something that's ongoing. There's a lot of people focused on the deep biosphere, but of course it's not an easy part of the Earth to study. But in terms of the majority of, say, biomass produced year to year, that's going to be oxygenic photosynthesis dominates that.
So the trend has been, now it appears to be at a stable level, or is it trending up or down?
If we were to look over the past, say, million years, and we take our cues from the ice core record, so the longest continuous record of ice, I think that they pulled up in Antarctica is about 700 million years 700,000 years, sorry. The oldest ice people have found at this point, I think is about 2 million years, but this isn't really a continuous record. But within that ice, there's little bubbles that contain CO2, O2, and give you a nice sample of the atmosphere. And when people have looked at the isotopes of that O2, they've come up with estimates of the productivity of the biosphere in a similar way that some of my PhD work did using ancient salts. And it appears that global productivity hasn't varied too much, which is a little bit unintuitive when you think of the last glaciations, for example. And the idea is that maybe the marine realm became a bit more active over these intervals of time. When we go further back, there might have been higher productivity, say, for example, in the Mesozoic, around the time when dinosaurs were around. But when we look on very long time scales, it appears that we're sort of in this stable, high productivity interval at the moment. Yeah.
What percentage of all carbon on Earth is cycled by life? Is there an estimate of that?
If we were to look at the total amount of carbon on the planet and ask how many times has the biosphere cycled that, for example, we would get an estimate that's about 100 to 1,000 times the amount of the total amount of carbon on the planet. So what does that look like? If you were to look out at the moon tonight, now just imagine all of that is just a ball of carbon, okay? That's about the amount that the biosphere has cycled over the entire lifetime of the planet, which is pretty impressive.
Yeah, but in relation to all the carbon on Earth, you say it's about 1,000 times, but over a huge time scale.
Yes.
So let's relate it to a year, what is the total production effect? What percentage of the carbon does it cycle?
In terms of a percentage...
Yeah, even if it's real crude, what will be your estimate?
Let's see here. I think it's 110 million a year.
Okay, so it's a very, very small fraction of all available carbon.
Keep in mind, though, that most of Earth's carbon is not at the surface. Okay, most is tied up in the deeper Earth. So the biosphere does not have access to... So in terms of the amount of carbon that's actually at the surface that the biosphere even has access to, certainly that number goes up quite a bit. However, I don't have...
Can you call that available carbon? And is there an estimate of how much there is there?
Well, you could think of it as say the amount of CO2 in the atmosphere just as a reference point, and that would be about a quarter of it every single year.
And what about the fraction in soils that plants and other creatures would have access to, and in the sea?
That I would have to get back to you on because I don't have those numbers at my fingertips right now, or the amount of dissolved organic carbon in the ocean in terms of real numbers at my fingertips here.
Okay, well, understanding these numbers, what does that lead to in terms of, thoughts? What consequences are there, what you figured out?
I think we're living in a time right now where we're looking at exoplanets. We're actually starting to contextualize Earth in relation to a lot of these other new planets that we're discovering every day. Of course, we don't have direct imaging of these things. A lot of our observations are simply sort of the amount of time it takes for these to orbit around their home star, maybe the mass of these things. But it's certainly caught the attention of a lot of public's interest, and a lot of researchers are thinking very hard about what these planets could be like. And one of the fun things about this work is that it sort of provides a benchmark of just, at some point life originated on this, third rock from the sun, and how much has it been able to house over that, say, 4 billion years of biospheric history to now. And we can even go further and say how much life will ever exist as the sun continues to heat up and eventually at some point the Earth will become uninhabitable. But this provides a benchmark to compare some of these other planets to, especially when we think about water worlds or places that we think could be habitable, which I think is a fun thing to think about.